Okay, so welcome back. Now we're going to do an example, and I'm going to show you how we add and subtract vectors. And the way we do it is we add and subtract component-wise. Okay, so let me show you. And then what I'll do is I'll show you on the graph as well. So let's say I wanted to get u plus v. Okay, so if I want to add these vectors, well, the way we do it, both of these are in standard position. And so the way we do it is we add them component-wise. Okay? So if we want this, we would write this as 3 comma negative 2 plus negative 1 comma 4. Okay? And so we would add, component-wise, we'd add the 3 and the negative 4. So it would become 3 plus negative 1, comma, negative 2 plus 4. And then we would have what? We would get 2, comma, 2. And so that would result in a resultant vector that ends at 2 comma 2, which would be located here. So 2 comma 2, which would be right about there. Okay? And so the idea is again, if you visualize this, if you take this vector here, oops, let me label these. So this is u, and that's v, right? So if you label these, and if you take this vector and you slide it down to the end of this vector, well, what do you get? You get this. Which is exactly, and then we end up with our resultant vector here, okay? Now, what about subtracting? Okay, well, again, it's just adding the negative, right? So we're going to have it go in the opposite direction, right? So again, if we have negative v, that would be 1 comma negative 4. Well, where would that be? 1 comma negative 4 would be this way. Okay, so then it would just be going the other direction. Okay, and so this would be negative v, right? And now what we would do is if we wanted to do the subtraction, right? So if we wanted u minus v, which equals the same thing as u plus negative v, well, that's going to be what? It's going to be 3 comma 2 minus or plus what? Negative v, which is 1 comma negative 4. Okay, and then we just add them component-wise. But again, if we subtract, we could subtract u and v, but again, we're just subtracting component-wise then. Same thing, okay? So here, we're going to get 3 plus 1, comma, negative 2 plus negative 4, okay? Which would give us 4, comma, negative 6. Now, if you do the subtraction and just subtract these two, you're going to get the same answer. You would just subtract 3 minus a negative 1, which would give us 4. And then you do negative 2 minus 4, which is negative 6. So you get the same answer. Okay? Now, let's plot this, right? So 4, negative 6. 4, negative 6 is right here. Okay? Now, so the resultant vector is going to be here. Now, if I, again, so to do it graphically, so here's negative v, here's u. If we do u plus negative v, or if we do u minus v, what happens? You're going to take negative v, right? So negative v plus, right? So when you add vectors, you go from tail to head, tail to head. So if I take this negative vector here and I slide this down to the end of this arrow here, well, what do I get? I get that. So it works, right? It adds up. And so that's how you see it visually, and this is how you do it just using arithmetic or using component-wise addition or component-wise subtraction. Okay, but to better see the subtraction and addition, we always do it in a manner of addition, because when you do it, when you add vectors graphically, it's easy to see that you just go from tail to head, tail to head. Okay, and then you draw the resultant vector from the tail of the first vector to the head of the last vector. So you could do this with 3 vectors if you had 3 vectors that you're adding, and so on. It would be done the same way. Okay, have a great day.